Hello everyone. I decided to go ahead and make a video to show you, parents especially, how we are doing our hands-on algebra lessons in our classroom. And the reason why we call it hands-on algebra is because we use a series of manipulatives, which are any handheld objects that can help make the math more concrete for students. And we use those manipulatives throughout the lesson rather than doing the algebra that you might remember just on pencil, using pencil and paper. So the objects that you see right here in front of me are those that we use every day to set up our equations. And I'll show you right now. I'm going to give you an example of an equation. Well, first of all, let me explain that what we have here is a scale. What we have here are what we call pawns. And here we have our cubes. Now, the scale represents where we will put our equation. This is the left side of the equation. This is where the equals would be in the middle. And this is the right side of the equation. The pawns represent any variable that has an x. So all the pawns are x's. The cubes represent the numbers that are not attached to any x's. It will all get much more simple for you in just a second. But let me show you an example of a problem. We might have a problem such as this. 2x is equal to 4. Well, in that case, to set up 2x is equal to 4, I would have to take 2 pawns, place them on the scale, and then a number 4 cube. This one does not have any, so I will take this one, place it on the right side of the scale. So now I have 2x is equal to 4. Then the student would simply figure out how many of what, 2 of what number is equal to 4. And they typically can figure that out in their heads, that x must be equal to 2. Once we've realized what x would be equal to, we write it to the right of our equation, where we always have a chart, a table, where we have one side labeled x equals and the other side labeled check. So we would write x is equal to 2. Now we have to do our check. We go back to the equation and we replace all the x's with a number 2 in our heads. So we would say 2 plus another 2 is equal to 4. 4 is equal to 4. So we would write that in the check column. 4 is equal to 4. And since we know that 4 is indeed equal to 4, we would put a check over the equal sign, and that means that we have checked our problem and it is correct. Now, let me give you an example of when somebody might do it incorrectly. Suppose they decided that x must be equal to 3. Well, they would write x is equal to 3, but then when they went back to do the check, they would find out that 3 plus 3 is equal to 6, and 6 is equal to 4 would be the check, and we know that that is not true. 6 is not equal to 4, so they must have done something wrong. That allows the student to go back and check his work. So let's move on to the next problem. First, I will take the pawns and put them back in my cupboard or on top of my shelf. That's what we ask all students to do so that they won't lose their manipulatives. The next one is 2x plus 3 is equal to x plus 6. Let's set it up. 2x plus 3, there we are, 2x plus 3 is equal to x, so I take another pawn, plus 6. There we go. That's my problem. 2x plus 3 is equal to x plus 6. What we've learned to do in problems such as this is to make sure that all of our pawns are on one side of the equation. We call that legal move number 1. And then we will make sure that all of our cubes are on the other side of the equation. We call that legal move number 2. Let me show you. So in this problem, I would either take the 2x, subtract 2 x's from this side, from the left side, and then subtract 2 x's from the right side in order to be legal. But I can't do that because I only have one x on the right side. So in this case, I would subtract 1x from the right side and 1x from the left side. I subtract by simply removing the pawns. So I remove one pawn from the right, one pawn from the left. The problem that I now have is x plus 3 is equal to 6. But my cubes are still on either side of the equation. So I will subtract 3 from this side and then 3 from that side. 3 minus 3 would be 0. 6 minus 3 would be 3. So now we have the problem x is equal to 3. We have found out what x is equal to. So I will write it here. X is equal to 3. And now I set up my problem again, my original problem, to verify, to check if x is indeed equal to 3. So 2x plus 3 is equal to x plus 6. Remember, I